Hello everyone, I am Abhishek. My roll number is 10197, and today we will be observing and or studying small signal analysis for BJT amplifier. So, this is the equivalent, this is the original circuit which we will be operating on, and this C1 and C2 here are the coupling capacitor for input and output respectively, and C3 is the bypass capacitor which bypasses the RE transistor. And this is done so to because the gain decreases if we do not apply C3 because of RE transistor. So as we have to make an equivalent circuit so that we can simplify and study this circuit. So as we know, the reactive capacitance of a capacitor is 1 by 2 pi Fc. Okay, but here our signal consists of DC and AC. Okay, now for DC signal, as we know, frequency is 0, so reactive capacitance becomes infinity. Capacitor acts like an open wire. But on the other hand, for AC signal, F is non-zero, but the capacitors in this circuit which we have taken are large enough, are very large, having very large values. So reactive capacitance as Xc is equal to 1 by 2 pi Fc. Frequency is small but capacitor is high, so Xc is overall small, and it's so small that it's almost tends to 0. So as we saw, for AC, capacitor acts like a short wire. For DC, it acts like an open wire. Okay, now for making AC equivalent circuit, we short all DC sources. Number 2 step, short all capacitors. Thirdly, we redraw the circuit so to get the equivalent circuit. As we short the circuit, we get this R1, here R2. The capacitor is being short, so this is the input resistance, this is R2, this is the AC signal source, and here is our BJT, this is RE, but since it is, this will be shorted as capacitor has been short. Okay, now further this thing is ground. Here too this will be ground. Since this is ground, we we connect these to ground also. These both to ground, connect them to the ground wire, and we get the equivalent circuit which would be looking like this. R1, this is R2, so taking the equivalent of these, the final circuit looks like this. This is the R equivalent circuit. This is the RL circuit. This is the plus, this is minus. So this is the equivalent circuit. Now for calculating equivalent model, we have hybrid. We will use the hybrid model now, which is the H parameter model. Parameters, this will be using our 2-port network where we don't have to think about the inside parameters which will be going on here, but we will now focus on the input and output parameters, which are these V2 and I2 are the output input, and I1 and V1 are the input parameters. Now here I1 and V2 are independent variables, and V1 and I2 are the dependent ones. So V1 and I2 will be functions of I1 and V2. And we see that V1 is H11 I1. We can generate it as a function like this, and H12 V2, and I2 is H21 I1 plus H22 V2. Now when V2 is equal to 0, V1 equal to H11 hi by I1. H11 is equal to V1 by I1 when V2 is equal to 0. This parameter gives us the input impedance, and secondly now H21 H21 which is this parameter from this equation, where if we this is when V2 is equal to 0, H21 will be equal to I2 to H21 will be equal to I2 by I1, which is equal to forward, which will give us forward current gain. Now H12 simply will give V1 by V2 I1 is equal to 0, reverse voltage gain, and H22 will give us output admittance, and this will be when I1 is equal to 0. Thank you. So this was the video for H parameter model, and this was me, Abhishek. um, and we'll